All right, today we're going to talk about a molecule you've probably heard of, homocysteine, but we're going to look at it in a completely different way. Not as some scary villain, but as this absolutely critical player right at the crossroads of your metabolic health. Let's get into it.
So just imagine for a second, what if there was one single molecule in your body that acted like an internal traffic report? Something that could tell you in real time if everything's flowing smoothly or if there's a major pileup on your internal highways. Well, that's pretty much the job that homocysteine does.
So what exactly is it? Homocysteine is an amino acid, but here's the catch. You don't get it from your diet. It's a temporary thing, a byproduct that's created when your body processes another amino acid called methionine. Just think of it like a metabolic crossroads. It pops up, and your body has to make a split-second decision. Which way do we send it? And believe me, that decision is a huge deal for the health of your cells.
And that brings us right to the main highways. See, once homocysteine appears at that crossroads, it really only has two primary fates, two main routes it can take to get cleared out of the system. Let's break down what those are.
This is such a great way to visualize it. On one side, you have remethylation. This is basically the recycling pathway. Homocysteine gets converted right back into methionine, which is a super useful amino acid. Then on the other side, you have transsulfuration. This is the conversion pathway. Here, homocysteine gets transformed into something totally new, but also incredibly important, cysteine.
Let's dig into that recycling pathway a bit more. It's like a finely tuned machine, but it absolutely needs the right fuel. For homocysteine to get recycled, it needs to grab a methyl group, and that process requires vitamin B12 and folate. The whole reaction is run by a really important enzyme called MTHFR. The final product? Methionine, which goes on to make SAMe. And SAMe is like the body's universal methyl donor. It's involved in regulating everything from our DNA to our mood. But what if the body's already got plenty of methionine? Well, it sends homocysteine down that other highway, the conversion path, or transsulfuration. Now this route, it needs a different fuel, vitamin B6. With some B6, homocysteine is transformed into cysteine. And this is just a brilliant bit of biological engineering because cysteine is the direct building block for glutathione, which is arguably the most powerful antioxidant your body makes.
So we've got these two really elegant pathways, right? Both are designed to keep things moving. But what happens when they get backed up? What causes a metabolic traffic jam?
Well, the causes are often pretty straightforward. The biggest one is just not having enough fuel, not having enough of those B vitamins we just talked about. Genetics can also be a factor, especially with certain variants in the MTHFR gene that make that recycling enzyme a little sluggish. And of course, lifestyle stuff like smoking or drinking too much can mess with how well you absorb B vitamins. When this traffic jam happens, homocysteine levels build up, and that's when it's linked to some serious problems, like damage to your arteries and even cognitive decline.
But, and this is where our bodies are just so incredibly smart, what if that main highway is blocked? It turns out the body has a built-in detour, a kind of backdoor pathway that can still get the job done when the main route is struggling. This quote from the source material really gets to the heart of it. It highlights that this isn't just some random thing that happens, it's a system we can actually support and encourage when that main highway gets congested. It's pretty empowering. So this backdoor is called the BHMT pathway. It's another recycling route that happens mostly in the liver and kidneys. And here's its superpower. It doesn't need the folate cycle or that MTHFR enzyme we keep mentioning. It completely bypasses the most common place where those genetic slowdowns can happen. Okay, so how do we fuel this special detour? Well, it runs on a totally different set of nutrients. Instead of folate, it uses betaine. You might also see it called TMG as a direct methyl donor. You find that in foods like beets and spinach. Your body can also make betaine from choline, which you'll find in things like egg yolks and liver. And lastly, the enzyme that actually runs this whole pathway needs zinc to work properly. So far, we've talked about the biochemistry, right? The roads, the fuel, the enzymes. But who's actually directing all this traffic? This is where it gets really fascinating. The ultimate traffic controller for all of these metabolic pathways is the state of your nervous system. Just let this one sink in for a second. Stress is a methylation thief. Every single time your body gets stuck in a state of chronic stress, it has to produce hormones like adrenaline. And making that adrenaline uses up the exact same resources, those precious methyl groups, that you need to clear homocysteine. Stress literally steals them to go do another job. Just look at this breakdown. When you're in a sympathetic state, that's your fight or flight mode, your body diverts all its energy to dealing with whatever it thinks the threat is.
Deep internal work, like liver metabolism where this stuff happens, gets put on the back burner. That is a metabolic red light. But when you're in a parasympathetic rest and digest state, that's the green light. The body finally gets the signal that it's safe to focus on maintenance, repair, and detoxification.
So how do you hit the brakes on stress and get that green light? It's actually way simpler than you might think. The sources lay out 3 really powerful ways to activate what's called your vagal brake. Just splashing cold water on your face triggers an ancient reflex that calms everything down. Extending your exhale, like with a 4-7-8 breath, is a direct signal to your nervous system to relax. And even something as simple as humming can stimulate your vagus nerve through vibration.
Okay, so let's put all the pieces together. We've got the biochemistry, we've got the right nutrients, and we know the role of the nervous system. We can combine all of this into a daily plan, basically a driver's manual for keeping your metabolic highways clear.
So here's what that looks like in the real world. It's not about one massive effort. It's all about small, rhythmic signals throughout the day. In the morning, getting some sunlight and doing some calm breathing sets your metabolic clock for the day. In the afternoon, a quick walk after lunch can help protect those methyl groups from stress. And in the evening, a little bit of humming or that 4-7-8 breath gets your body ready for a night of deep repair.
And this, right here, is the key takeaway of this whole thing. It is all about consistency over intensity. You get into metabolic alignment not by doing something extreme, but by stacking up all these small daily signals that tell your brain that your environment is safe. And when your body feels safe, it can finally prioritize long-term health, repair, and keeping those metabolic highways flowing free and clear.
So I'll just leave you with this one question to think about. When you look at your own daily routine, how you eat, how you move, how you breathe, how you handle stress, are you creating a metabolic traffic jam day after day, or are you paving a clear-flowing highway? The power to decide which one it is, that's all yours. Thanks for tuning in.